Hi everyone and welcome back to Exam Ignite. In this video, we are starting Module 2, Part 1 of Principles of Communication System for VTU syllabus, 4th semester 2022 scheme. Just like the previous videos, these are exam-focused handwritten notes made simple and easy to understand. All the topics are directly taken from the syllabus and I have referred the model question paper 1 and 2, previous year question paper January 2025 and July 2024 exam papers. Topics from which the questions have already appeared are clearly explained in detail. So you can expect the most expected questions from this module. So stay with me till the end of the video and let's get started with the module 2 part 1. If you have not referred the previous videos, do refer the description box. The module 1 video is already updated and you will get it. So, principles of communication. Here, the topic is amplitude, modulation, and fundamentals. We are studying about AM concepts, modulation index, percentage of modulation. These two topics are important as it has been asked in the 3 papers. Next, sidebands and frequency domain. It is in 2 papers. Then AM power. Based on it, there are problems asked, and even the concept that derivation is there, that is also asked. Then single sideband modulation. AM circuits, here amplitude modulators, diode modulator, transistor modulator, and the collector modulator. Square law circuit and the expression for the AM is asked in model question paper 2. Next is amplitude demodulators. Here diode detector, which is an important because it is asked in the 3 papers. Next, balanced modulators, that is the lattice modulator, that is also asked in 3 papers. Then frequency division multiplexing, that is transmitter multiplexer and receiver demultiplexing. This is also important. Program, the main lab program, that is MATLAB code to generate the amplitude modulation and demodulation waveforms. Learn the code. First topic, we have to know what is amplitude modulation fundamentals. In the modulation process, the baseband, voice, video or digital signal that modifies the another one, that is high frequency signal, that we call it as carrier signal, which is a sine wave. AM concept, first topic, the information signal varies the amplitude of the carrier signal sine wave. Now the instantaneous value of this carrier amplitude changes in accordance with the amplitude and the frequency variations of the modulating signal. Carrier frequency sine wave remains constant during the modulation process, but the amplitude varies in accordance with the modulating signal, that is it decreases or increases in both positive and negative peaks. So we can say the imaginary line that is connecting the positive peaks and the negative peaks of the carrier waveform gives the exact shape of the modulating information signal. That imaginary line on the carrier waveform is called as an envelope. So this first one, let us consider this is a modulating signal versus VM versus time into a graph. So here this is a carrier signal. What do we get? We get a modulated signal. This is our AM signal, which is a carrier peak is 0 reference for modulating signal, and here it is unmodulated carrier signal. Okay, then it forms an envelope. This is an envelope. Using the trigonometric functions, we can write the two equations. That is, small vc is equal to capital VC sine 2 pi fct. Here our small vc is the instantaneous value of the carrier sine wave voltage at some specific time in cycle. Capital VC is the peak value of the constant unmodulated carrier sine wave, that is between 0 to maximum amplitude. Fc is our frequency and T is the time at that particular point. Next, for modulating signal, we can write small Vm is equal to capital Vm sine 2 pi fmt. Same here, instantaneous, this is instantaneous value, this is a peak amplitude, and Fm is my frequency of modulating signal. The envelope of the modulating signal varies above and below peak carrier amplitude. That is, zero reference line of modulating signal coincides with the peak of the unmodulated carrier. Generally, you can say amplitude of the modulating signal is less than the amplitude of the carrier signal. If it is greater than will occur, then the peak of the modulating signal will be less than the peak of the carrier signal. In case of distortion, using carrier is reference point for the modulating signal, then the modulating signal is added or subtracted. So the instantaneous value is top or bottom envelope is given as V1. That is, we will define V1 as Vc plus Vm. So on substituting the Vm from the equation 1, we can write it as capital Vm sine 2 pi fmt. Now the instantaneous value of the complete modulated wave, that is V2, we will consider as V1 sine 2 pi fct. So V1 is substituted as this from the equation 3. So we can write V2 is equal to V1, that is this, and sine 2 pi fct. Multiply it with the inner section, that is Vc sine 2 pi fct, and this Vm sine 2 pi fmt. Multiply for the both, and now open by the formula. So you will get it as Vc sine 2 pi fct plus, here we have to apply the formula Pm by 2 of cos of 2 pi fc t plus 2 pi fmt minus cos of 2 pi fct minus 2 pi fmt. So this is my AM high frequency sine wave, how it looks. So the modulating signal envelope is this. So you can say consider that V maximum, this is my V maximum, this is my V minimum. V minimum peak to peak is this, and V maximum peak to peak is this line. Equally spaced vertical lines represent that there is a constant frequency carrier sine wave. So you can think like information or a modulating signal is given to a modulator along with a carrier signal. This is Vm and Vc is given, and we get the output as this. Next is the main concept, which is important for your exam. They'll ask you to explain the modulation index and the percentage of modulation. Either they may ask you problem or to explain. So if they ask to explain, first write the definition, that is the ratio of the change in the amplitude of the modulating signal to the carrier signal is called a modulation index. You can say it modulation index, or you can say it modulation factor or modulation coefficient, or the depth of the modulation or the degree of the modulation. They can ask you in any format. It all seems as modulation index, that is represented by small m, that is Vm by Vc. So you have, for the percentage of modulation, just you have to find the multiply it with 100. You have to explain the case of over modulation and distortion. Actually the modulation, it should be less than 1 and it should be greater than 0. This condition has to be obeyed. If it is reversed, that is if m is greater than 1, that causes a distortion. Distortion means we get a waveform like this, which is an unnatural sound. This envelope is no longer in the shape of the modulating signal. There is a clipping of the negative peaks happened here. So this is called distortion. For an ideal AM amplitude modulation, Vm is equal to Vc, that is 100% modulation. So the solution is what? We use compression circuits automatically solved by amplifying low level signals and suppressing or compressing high level signals. Next concept, this is along with that is the percentage of modulation. The peak value of the modulating signal Vm is 1/2 difference of the peak and the trough values. So you can write it as Vm is equal to Vmax minus Vm divided by 2. So Vmax is given by what? This one is given by Vmax is equal to V maximum peak to peak divided by 2. The peak value of the carrier signal Vc is an average of what? Vmax plus V minimum divided by 2. This is for the Vc, where V minimum is given by V minimum divided by 2. Modulation index becomes what? It is we know Vm by Vc. So we can write it as V maximum divided by V maximum minus V minimum divided by V maximum plus V minimum. You need to write this graph again while you are explaining this percentage of modulation in the exam. Okay, next is the sidebands and frequency domain. In this, the sidebands or the side frequency, it's a new signals at a different frequency are generated as a part of process when a carrier is modulated by the information signal. Sideband calculation is what they may ask you the problem or they may ask you to explain also. Sideband is given by FUSP, that is upper sideband is FC plus FM, FLSP is FC minus FM. So bandwidth is given by FUSP divided by FLSP. Next, bandwidth is 2 times the, when you consider that FUSP and FLSP have FM, then when you substitute this FUSP value and FLSP value, you get bandwidth as 2 FM. On substituting that, so VAM, as we know in the before we have already derived this equation. In that, you can observe the first term is a carrier, second term is the lower sideband. As you can observe that there is FC minus FM here, and the next last one is the upper sideband, which is because FC plus FM. You need to write this diagram for while you are explaining the sidebands. This is our modulating signal. First one is our modulating signal. Second one is our lower sideband. Third one is the carrier signal. Fourth one is upper sideband, and this will be your AM wave. So all these are instantaneous amplitudes are added to produce their sum. Now next is the main important topic, that is frequency domain representation of AM. That is, you can say this is actually the diagram where the frequency domain display of AM signal. This will be our LSB, and this will be our UFUSB, and this will be your FC. This is a plot of the signal amplitude versus the frequency, that is called as a frequency domain display. The test instrument is known as spectrum analyzer, is used to display the frequency domain of the signal. You need to write this representation, that is relationship between the time and the frequency domain, where time and the frequency are perpendicular to each other. This will be my carrier, this will be my upper sideband, this will be my lower sideband. Here it is the peak amplitude values of sine wave, that is FC plus FM, FC and FC minus FM. This will be my amplitude, and the frequency are perpendicular to each other. So finally, I will be getting the AM time domain. Clear. Next is voice, which is the voice frequency lies between the 300 to 3000 hertz. That we have to represent it in the waveform, that is, sorry, in this format, upper and lower sidebands of the voice modulator AM signal. Here it is FC minus 3 kilohertz, that is left hand side it is 3 kilohertz. For the right hand side it is FC plus 3 kilohertz. This is our carrier frequency. You can observe this is 3 kilohertz and this distance is 3 kilohertz. This is for the voice signal. Next concept is AM power. This is what I said, the derivation they will be asking. The total power transmitted is equal to what? PC plus PUSP plus PLSP. Power in the carrier, power in the upper sideband, and power in the lower sideband. Sum of all this is called as a total transmitted power. We know that what VAM has, we previously learned we have 3 terms: first term, second term, and third term. So VCM and VM are what? We are having the peak values here. To calculate the total power, we need to calculate in the RMS. So what we know for the RMS, we should divide by √2. Or you have to multiply it by 0.70. So this equation will become VC divided by √2, VM divided by 2 √2, and here VM divided by 2 √2. Finally, we know by the power equation, P is equal to what? V square by R. Substitute it now. Total power is what? V square. What is V here? V here is VC by 2. And here it is VM by 2. And here it is VM by 2 √2. That you are going to substitute here, that we will get whole square divided by R. So on substituting, the square and the square root will get cancelled. So we get VC square by 2R plus VM square by 8R plus VM square by 8R. So on adding these two, before adding, we have to substitute. VM is equal to, by the modulation index, we know this, M is equal to VM by VC. So substitute in the place of VM, that is MVC, and here also MVC. It becomes M square V square, and remove the V square by 2R as common. outside, you will get it as 1 plus m square by 4 plus m square by 4. Total power will be what? PC of 1 plus m square by 2. This is an important equation or the formula you should know to solve problems. So PSP, SP on both the sides, it is given by P total minus PC, and PSP of one side is PSP divided by 2. Sideband, one sideband. P is equal to V square by R. PT is equal to what? This is another one formula, that is IT square R. So IT is what? IC square root of 1 plus m square by 2. We will get another one formula for the modulation index. PSP is equal to PLSP is equal to PUSP is equal to PC m square by 4. This is required in case of the problems. But for the derivation part, you have to write till this point. Next, carrier signal itself conveys no information. So it needs to be transmitted and received, but unless modulation occurs, no information is transferred. So what? Modulation occurs in the sidebands produced. Therefore, the transmitted information is within the sidebands. 1 by 3rd of the total power is what it is allotted to sidebands. 2 by 3rd is wasted on the carrier itself. Despite this inefficiency, AM is widely used because of why it is simple and it is effective. It is used in where we use it in the AM radio broadcasting, CB radio, TV broadcasting, aircraft tower communication, simple control radios, that is ASK, garbage doors openers, then remote keyless entry devices on cars. So AM is widely used in combination with the phase modulation to produce the QAM, that is quadrature AM, which is of a high speed data transmission, that is in the modems or TV cables in wireless applications. So the last topic of this video, part 1, is a single sideband modulation. Here we are having two. One is DSP and SSP. In AM, 2 by 3rd of the power is what? Carrier. It conveys no information. So the real information is transmitted through what? Through the sidebands. To improve the efficiency of the AM, we need to suppress the carrier and we need to eliminate one sideband. If we eliminate one sideband, it becomes single sideband. If we suppress the carrier, it becomes double sideband. The first step of generating the SSP is suppressing the carrier, leaving the upper and lower sideband. So that is why we call it as double sideband suppressed carrier, DSSB. SSC or DSB. Benefit here, no power is wasted on the carrier. The special case of AM where we have no carrier, this is what our DSP. The time domain display of the DSP is given like this. You can observe here there is a node phase transistor transition here, transition of between those two, or else it would have gone directly. So this is a carrier frequency, this is the time. Next, the signal algebraic sum of the two sinusoidal sidebands is what its signal produced when a carrier is modulated by a single tone sine wave information signal. So carrier is suppressed. The time domain DSP is a sine wave at FC, varying the amplitude. You have to note that the envelope of this waveform is not same as that of the modulating signal that I have showed previously. As it is in the pure AM with carrier. That was pure AM with carrier. Unique characteristic of this is the phase transition that occurs at the lower amplitude portion of the wave. In wave figure as we have two adjacent. One is positive going half cycles at the null points in the wave. By this way, we say signal is 2 DSP. This is one sideband and this is another sideband. This is what suppressed carrier. So we are mentioning it in the dotted lines. It is suppressed. This is a frequency domain display of the DSP. This is a spectrum space that occupies by a DSP, same as that of the conventional amplitude signal. DSSC are generated by the circuit called as a balanced modulator, which we will be learning later in the amplitude demodulation topic. So that produces a summand of difference frequencies, but to cancel or balance out the carrier. The disadvantage of this is difference to demodulate recover at the receiver. It is very difficult to demodulate. Next, what is the application of DSP is the transmission of the color information in the TV signal is done through this DSP. Second part is SSP, that is single side suppressed carrier. That is this is a sum or and difference of the carrier and the modulating signal information is in both the sidebands. No reason to transmit both sidebands to convey information. One sideband can be suppressed. Remaining sideband is called as in what? Single sideband suppressed carrier. Here one sideband is suppressed, one more is there. So here what is the benefits? It occupies only 1 by 2 AM and DSP. This conveys what spectrum space and allows more signal to be transmitted in the same frequency range. First benefit. Second thing, you can carry it further area and it is more reliable and received at the greatest distance. So this is an alternative SSP can be made smaller and lighter because it has less circuit and power consumption is low. Because of this SSP occupy narrow bandwidth, amount of noise will also be reduced. The less selective fading of the SSP over a long distance. These are the 4 benefits. You can observe here, this is a frequency and time domain display of the SSP. Here, this is also suppressed and this is also suppressed. Only last one SSP is working. That is only used for the transmission. Here you can observe a sine wave of the SSP signal. So AM produces SP, that is of this megahertz. In SSP, only one sideband is used. The upper sideband is only the upper one is generated. You have to note this is generated. RF signal is constant power, that is 14.302 megahertz sine wave. Disadvantage of DSP and SSP, both of them is it is actually hard to recover because demodulation at the receiver is not that easy. Then demodulation depends carrier being present. If there is no carrier, then it must be regenerated at the receiver and reinserted into the signal. Carrier must have the same frequency as those of the original frequency, which is a difficult task. Then SSP, when SSP is used for the voice transmission, reinserted carrier can be made variable in the frequency so that it can be adjusted manually while listening to the receiver intelligible signal. This is not possible for some kind of data. The another one thing is to solve this problem, the low level carrier signal is transmitted along the 2SP in DSP, 2 sidebands in DSP, or 1 sideband in DSP. Carrier has low power level. The essential benefits of the SSP are retained but a weak carrier received so that it can be amplified and reinserted to remove the original information. So the pilot carrier, it is used in the FM stereo transmission color information in the TV picture. Signal power consideration. This is just an you need to know the formulas because they might ask this module maybe you may expect a problem from this module. So to know that, I have just written a basic formula that you have to remember. PEP, that is peak envelope power. It is VRMS by R. What is VRMS? Then VRMS is V peak to peak divided by root 2 or 0.707 P peak to peak. Sorry. PEP input power is DC input power of the transmitter's final amplitude stage at the instant of voice envelope peak. Its final amplifier stage, the DC supply multiplied by the maximum amplifier current that occurs at the peak. So you can say PEP is Vs Imax. If the question they have given as Imax, then you have to use this formula to find PEP. P average is given as PEP by 3 or PEP by 4. This was all about the second module's part 1 video. I hope you have got all the concepts clearly. This helped you to understand the important concepts. So I have done already the previous module, that is module 1 part 1 and part 2. The links are in the description box below. So don't forget to like this video, share it with your friends and subscribe to the Exam Ignite so you don't miss the upcoming parts and solve papers. Thank you for watching. See you in the next video.